What happens if you put a ball on the turntable? You might think it would definitely be thrown out. But the opposite is true. Not only will it not be thrown out, you give it a push. It can even rotate circles regularly on the disc. If you put a coin on the turntable, so in just a few seconds, it will be thrown flying. If it is a toy car, then this process only takes a moment. So why on earth do balls counterintuitively stay on the turntable? Even after a push, it regularly turns in a circle. Watch the ball carefully. We can find that. Every time the disc rotates 7 times, the ball will also rotate twice on the disc. No matter how big the ball we change, this ratio of 7:2 will not change. Leave this strange ratio aside for now. You just have to look at it from the side. We can see why the ball can fly off the disc without being thrown. We place the ball on the turntable when the ball remains stable. At this time, the air resistance of the ball is extremely small because the ball doesn't move in the air. It rotates in place. When the ball is in this stage, the ball rotates at the same speed as the surface of the turntable moves. So, in the eyes of the small ball, it just rolls forward in a straight line at constant speed, like a person on a treadmill. Although moving forward, but it still stayed in place. If air and other resistance are ignored, the ball can theoretically go all the way, and so it is. When we replace it with a smoother disc, the ball can also roll on the disc for a longer time. But when we made a referral to the ball, at this time, the rotation speed of the ball will be faster than the turntable. The speed of the turntable cannot completely offset the speed of the rotation of the ball. Therefore, it is naturally small. The ball will move in this direction, and when the ball rolls to a new position, so what happens? When the ball rolls to the periphery of the turntable, because the speed on the outside of the disc is faster than in the turntable. Therefore, the speed of the turntable relative to the ball will increase a little. Therefore, the ball is pulled back to the more central position of the disc, and when the process repeats itself, the ball goes around on a disc. In fact, this phenomenon was discovered in a paper published in 1979. According to the author's mathematical analysis, the orbital period equation of the spheroid can be obtained. If it is a solid ball, so relative to the turntable, the ball rotates twice every 7 laps. And if the ball is hollow, like a ping pong ball, then the ratio will become 5:2.